Welcome to the complete Python Pandas tutorial. Built on NumPy, Pandas is the most powerful library for cleaning, analyzing, and preparing structured data. Whether for basic analysis or machine learning, this is your essential tool. Pandas relies on two core structures. A series is a one-dimensional labeled array, essentially a single column. A data frame is a two-dimensional table with rows and columns, acting as a collection of series sharing the same index. Create data frames easily from Python dictionaries. Keys become column names, and values become data. Indices are automatically generated starting from 0, or you can specify your own custom index. Load external data with read_CSV. Customize your import using parameters like sep for delimiters, header for row labels, and index_col to define your index. It's the standard entry point for analysis. Pandas supports many formats. Use read_Excel for spreadsheets, read_JSON for web data, read_SQL for database queries, and read_Parquet for big data. Each function comes with specific parameters to handle file nuances. Inspect your data immediately. Use head and tail to view the first and last rows. Check shape for dimensions, columns for names, and dtypes to ensure your data types are correct before diving deeper. Get a holistic view with info, which reveals missing values and memory usage. Use describe for instant statistical summaries of numerical columns, including mean, deviation, and quartiles. Select a single column using bracket notation with the column name string. This returns a series. While dot notation exists, brackets are safer for names with spaces or special characters. To select multiple columns, pass a list of names inside brackets. Notice the double brackets. The outer set is for selection. The inner set creates the list. This returns a new data frame. Use iloc for integer-based selection. It works like Python lists, zero-based and exclusive at the end for slices. Use it when you know the numerical position of your rows. Use loc for label-based selection. Unlike iloc, loc includes the last element of a slice. It's powerful for custom indices like names or dates. Use loc when you know the row label. Combine row and column selection by passing two arguments to loc or iloc. The first selects rows, the second selects columns. This precise syntax lets you extract exact data subsections. Filter data using Boolean masking. Create a condition to generate a true/false series, then pass it to the data frame. Only rows where the condition is true are kept. Combine conditions with ampersand for and pipe for or. You must wrap each condition in parentheses due to Python's operator precedence. This allows for complex logic within your filters. For cleaner syntax, use the query method. Write conditions as natural strings using and or. It improves readability significantly when handling multiple complex filters. Add columns by simply assigning a new name. You can use vectorized arithmetic to compute values from existing columns instantly, or assign a single value to broadcast it across all rows. Rename columns using a dictionary to map old names to new ones. This is selective and safe. Alternatively, assign a list to df.columns to rename everything at once. Remove unwanted data with drop. Pass an index label to drop rows, or a column name with axis =1 to drop columns. Remember, this returns a new data frame unless you use inplace =true. Missing data appears as NaN, distinct them with ISNA, and chain it with sum to count missing values per column. Understanding these patterns is crucial for your data strategy. Handle gaps by dropping rows with dropna or filling them with fillna. You can fill with 0, the column mean, or propagate adjacent values. Choose the method that fits your analysis context. Group by is the engine of aggregation. It follows the split-apply-combine logic, splitting data into groups, applying a function like sum or mean, and combining the results into a new table. Apply standard statistics to your groups. Use the AGG method to apply specific functions to specific columns or multiple functions at once, creating powerful summary reports in one line. Sort data with sort_values. Control the direction with the ascending parameter. You can even sort by multiple columns to handle ties, organizing your data exactly how you need it. Merging combines datasets. Inner join keeps only matches. Left join keeps all original rows plus matches. Outer join keeps everything. Visualizing these sets helps you avoid data loss. Use pd.merge to join tables on a common key. Specify the join type with how. If column names differ, use left_on and right_on. This is essential for relational data analysis. Concatenation stacks data frames. Default vertical stacking adds rows, while axis equals 1 stacks columns. Use ignore_index to reset the index if the original labels don't matter. Pivot tables reshape data for reporting. Define your index, columns, and values to summarize raw logs into a readable matrix. It's the Python equivalent of Excel pivots. Apply lets you run custom functions across rows or columns. While flexible, it can be slower than vectorized operations. Use lambda functions for quick, one-off transformations. Access vectorized string methods via the .str accessor. You can change case, split strings, or search for patterns efficiently without looping through rows. Convert dates using _datetime. Then use the dd accessor to extract year, month, or day. This unlocks powerful time series features like resampling and window functions. Export your results to CSV, Excel, or JSON. The syntax mirrors the read functions. Remember to set index equals false if you don't need to save the row numbers. Efficiency matters. Prefer vectorized operations over loops, handle missing data early, and use method chaining for readable code. Practice on real datasets to truly master Pandas.